which is kind of nice actually.
Yeah.
Like it's not getting progressively harder and more challenging. It's sort of like, yeah, we're experts now, right?
We're all
You know, we've,
experts and now
we've
we get to
almost got our
relax.
certificates. We're in a state of flow. It's
Well,
good.
yes, the flow state. The flow
We're
state is how you
observing
get.
every time it's dark and no clouds,
Yeah.
no smoke, because you've been getting the smoke.
No, it's more or less stopped now, but we did have it for a little while, a little longer than the last episode that we had.
Yeah.
Yeah, it is. We're getting to the easier side. It is interesting, and also just a heads up to the folks who are joining, and it is 3:30, I guess, so we can officially get started. But on our last three, we're on our third last episode now. It's episode 8, and we have 10. So we're almost at the end. And on these last 3 episodes, we have fewer targets, because we're getting to that point where we're about to hit as many targets as you officially need to get your Explore the Universe certificate. So if there are any targets that you really want to see, or that you haven't found, or you've had extra trouble with, please do let us know. You can, I would say probably the best way to do that is email me at jenna.hinds, HINDS, @rask.ca. I'll put my email in the description of the YouTube video as well. And then just let me know what you want to see in the, whoa, that's not right. Sorry, I sent it to the Zoom chat. There we go. Let me know what you want to see, and we can maybe cover some of those extra topics in the last little bit before we end for the winter.
Yeah, because we don't really cover a lot of winter targets, and winter is one of the best times to stargaze, just because the night is so long, the air is crisp. You don't need to de-dew your telescope as much if
And
you're
you can
observing when it's -10.
you can go and observe when it's like 8 o'clock at night, and that's dark. It's dark then, so it does help having the winter. And
Yeah.
yes, Mahika, so have I. If you've missed targets, don't worry about it. They're going to be up there forever. Well, for our foreseeable future. So
Yeah, and if you miss targets that we talked about, you've got the PDF of Explore the Universe, and just knock some of them off from the current and the next season. Because the winter constellations rise in the east at midnight. So if you wanted to pull a late night and just knock off all the winter, you've got all the winter hexagon there, and Gemini, Orion.
yeah, there's some really cool stuff.
All those great
We're going to cover
Sirius and Canis Major.
Yeah. We're going to cover some of the winter targets in the last couple sessions, and especially in the last session, we'll give you like a little Kickstarter for the winter season. And there's also a possibility that we'll continue in some fashion, either with Explore the Universe, or possibly we're in talks about doing it with Explore the Moon.
That would be great fun. I know Dave Chapman's, I saw him in the chat, he's probably ecstatic.
Yeah, so it's the nice thing
out of his chair. Explore the Moon show.
And Explore the Moon is really nice because even if you're in a city, so I've found, especially when I'm in the city, and Phil has found this too, it is really hard to catch all the targets that you need for Explore the Universe. So Explore the Moon you can do from the city. And if you're really dedicated and you have perfect weather, you can do it in a month. We won't do it in a month, but you could.
Mm-hmm.
And so that's our probable next plan for observing. But we're going to take a bit of a break to between the end of Explore the Universe and the next time that we offer one, because we've also got some exciting stuff going on at National Office, which everyone will hear about over time. So, okay. Anyway, on to the exciting news that's happening right now.
Let's dive in.
Is Mars. It's about to be Mars times. This week we're going to talk about a bunch of the planets. We have 3 non-planetary targets this week. This is an exciting week because planets are great to observe when you're in the city. You can see them pretty much everywhere. And the particularly exciting one is that it's Mars' closest approach on October 6th and the opposition on October 13th. So that means it's going to be bright and it's going to be beautiful. So when I say closest approach, it's just the way that our orbits work. If my nose is the sun and we've got the Earth and Mars, we are catching up to Mars. And then we're going to be really close, and then we're going to go past. And so when we catch up, the Mars is going to be real bright, easy to see. Yeah. And it's also why and we can rescue Mark Watney, that too. It's also why I bought my telescope in the first place, was for this closest approach. It's the closest we will be for another 15 years. And it's the brightest it will be in the sky. I mean, every 2 years we get close to it, but this is the brightest and closest approach for the next
this is one of the best. the primary reason why this is one of the best is because it's high in the sky. So you get a lot of approaches where for us, it's not that high. And so you get that atmospheric aberration. But this is why right now, if you go on Twitter, you're seeing all these fantastic views of Mars taken by people with their backyard telescopes. That's because it's above all the enough atmosphere that, you're able to get these good pictures that you can't get with something low on the horizon. So this is really the perfect time to observe it.
That too. Yeah. It's so if you think about Jupiter and Saturn, for example, we see them most of the time in the summertime. And because it's the summer, the sun is really high in the sky, but alternatively, the moon and the planets at night are really low in the sky. So there is a lot more atmosphere that we see through them, or we have to look through to see them. And so, yes, it's fall. And that means that Mars is going to be high up in the sky and it won't be too cold, which is nice. And it won't, it's going to be exciting. So just a quick overview of what we've got on. We have an Insider's Guide to the Galaxy, which is our Tuesday session with Chris. We have an episode all about observing Mars on Tuesday next week. And then the Tuesday after that, which is the opposition date. So it's not as close as Mars will get, but it's technically as the three of us, Sun, Earth, Mars, line up. That's on October 13th. And we're going to have a little star party. John's going to be there with a telescope that he bought just for the occasion.
I did. I'm so very excited. I'm testing it, except it's been so cloudy. I need like clear skies.
I know. I hope that there's clear skies that night. Even if there aren't, we have Chris Vaughn joining us from Toronto as well. And I'm up here on Manitoulin. So if I've got clear skies, I'll be able to show some images as well. And we have other images that other RASC members have taken and videos and stuff like that for us too. Yep. And we should have a guest as well. And that's the plan right now. And we'll have a little discussion about Mars exploration and life on Mars and that sort of stuff. Okay.
Yeah. So are you going to do a little do you have Stellarium open?
I'm going to open it up right now.
And then, so what type of telescope did you get in anticipation of seeing Mars with it? So, because I think so you go ahead and then I'll talk about telescopes.
I tried to choose, because I know myself, I tried to choose a telescope that I would actually use. And so I've got a Celestron NexStar 6SE, which I know is not specifically for planetary observing. But I also have some dark skies and I wanted to use it for other stuff as well. I didn't want to use it just for planets. And so I tried to find like a balanced midpoint on telescopes for.
So I would say that telescope is the perfect telescope for planetary observation. And there's sort of two reasons. So that series of telescope, it's a Schmidt-Cassegrain design. They have a really high focal ratio. So it's f10, I think. And that f10 and beyond telescopes are almost optimized for planets.
Oh, I didn't know that. Okay, yeah. Cool.
And so you can get high magnification. It's great. And then so you've got the six, right? Mm-hmm. So as you get larger telescopes, you can, when you're looking at planets, the image can get shakier because of the sky. But the telescope is almost optimized to account for atmospheric disturbances. And so that's why you get so many great photos of people using that telescope. And then so I got the 8SE and I've just mounted it on an EQ mount. And so we're both going to be able to get great pictures of Mars, or great views of Mars with just your eyes.
Mm-hmm. Yeah, that too. Yeah. And there was a question just briefly in the chat as well. Will Mars be very viewable and photographable? I don't know.
Yep. For weeks,
you can take pictures
absolutely.
of it. So yes, it will. It'll be visible for weeks. A month or so. At least until November. And it has been in a really good position now for about a month or so. And so, yeah, we have lots of time. It's not like that's it. You miss it on the 13th and it's done, or you miss it on the 6th and it's done. If you don't have good weather, just go out the day that you have good weather. You'll still be able to see it. And in this case as well, since it's a planet, you don't really have to worry about the moon phase either. So even if it's a full moon, go on and take a look.
Yep.
Okie dokie.
So you want to do Stellarium and then I'll maybe do astronomy tools for a minute?
Yes. Sounds good. So do you want to do astronomy tools first? Sorry? Or you want to do it after?
Yeah.
You go first.
Okay, screen share. So astronomy tools, and it's literally astronomy.tools is a website. And this is astronomy.tools/calculators. And basically what you do is you put in either what type of telescope you have or just the sort of stats on your telescope. And what it does is it simulates what you can expect to see with that setup. And so if we do, Jenna, your telescope, which has, I think, approximately 2000 millimeters of focal length, and then we're going to
Yes.
put in your eyepiece, like let's say for planets, you use a low focal length eyepiece, let's say 8, and that's pretty low. And then you put in what kind of,
a heads up, the lower the eyepiece, the larger the image. So if you have a 15 millimeter eyepiece and an 8 millimeter eyepiece, the 8 millimeter eyepiece will quote zoom in more.
Yeah. So to calculate magnification, you divide the focal length by focal length of the eyepiece by the focal length of the telescope. So 2000 divided by 8 would be your magnification, and then you multiply it by any Barlows that you're using. So that's a lens that goes between your eyepiece and the telescope. And so basically what I'm going to do here, I've selected Mars, and I've put in the focal length of the telescope and the eyepiece here. And aperture as well. What's 6?
Is, oh no.
6 inches in centimeters. What's
Hold
that,
on.
Siri? What's 6 inches in millimeters?
It's 15 centimeters.
The answer is 152.4 millimeters.
There we go.
Okay. Yeah. Okay, so I'm going to add that to the view, and that is what
Oh.
Mars will look like in your telescope with those settings. Isn't that great?
Okay, that's actually super exciting. That makes me really excited for the opposition.
Yeah. So you can see here we've got the ice cap. There's the 2 different colors of, so you may need to use a moon filter as well, and this assumes clear seeing.
That's okay, fair.
Yeah. But the size is pretty close.
And a heads up as well that the orientation, Mars's day is like an hour longer than ours. So if you look at it the same time every night, you'll see it in Mars an hour later or an hour further along in its turn. So if you want to see a specific side of Mars, you can kind of calculate. If you go out and you look and you want to see the other side, you'll have to wait 12 days for something like that for it to go around like a half turn, and go out at the same time, or go out.
I never even thought about it like that. So Mars has sols, and so you're saying 12 Earth days, and
12 Earth days.
Get
you 12. Yeah. 12 and a half Earth days. Close enough.
Cool. I think the JPL people that work on the Mars rovers have Mars watches that are on Mars time.
Oh.
So it's a 25-hour clock.
Oh, that's really cool.
Yeah. So cool.
Oh, that's super neat. That's a really cool website. I have sent out the link both in the Zoom chat and in the YouTube chat, and I'll add it to the YouTube description as well for later, because that's pretty cool.
Yeah, and just remember, like the more magnification, the sort of harder it is to get it in focus and to get it on target. So like definitely if you have a telescope, start with low magnification and then, work up. So smaller eyepieces.
Mm-hmm.
Because hypothetically you could go insane, and let me get rid of the yellow one here, and do this, but it won't look like that because you'll run into limits of the atmosphere. You'll run into the resolution limit of your telescope, all sorts of stuff. So you could bring it in like this, but it would be blurry.
Yeah, it wouldn't be easy to see.
Wouldn't be good.
Cool. So Mars is one of our targets on our list for like our goal targets this week. Excuse me. And because it's at opposition, that means that it's rising pretty much as the sun sets. So you'll see it right after sunset rising in the east. And it's going to be, the nice thing about the planets is they're like the brightest things around. So it's really hard to mistake them for something else. It's going to be bright, it's going to be orange, and it's going to be rising right after sunset in the east. I'll show you where it is on Stellarium as well. So that and a couple of the other planets are our targets too. So let's jump over to Stellarium. We have no lunar targets this time. So John, we can't use your book. I'm sorry. I know, very sad.
Well, you get 1 tier.
One single tier. Okay, so I'm going to go through. We have our technically I included Mercury in our planetary targets, but I'm going to explain why that was a mistake. And then we also have Venus and Mars as well. Yeah. So let's start with Mars because it's easy and you can see that. Yeah.
Oh, I'm just saying someone's hammering outside my door, so that's what that banging is. So.
All good. So here's our night sky tonight at 7 o'clock, 8:45. And there we've already got Mars rising. So this is the one good thing about the days getting shorter is that it's easier to catch observing time. So as usual, we do still have Jupiter and Saturn up, which are up in the south in our sky. And then off to the east, we've got Mars rising. I'm going to give you guys a little bit of just a demo as to how bright this is going to be over time. So there's Mars and its two little moons.
You won't
And
see
you
the
can-
moons though.
Yeah, you won't
They're
see
too
them.
small.
They're too small. So we've got, where's the brightness here? Absolute magnitude. Let's go with magnitude. So it's right now it's minus 2.5, which is real bright. That's brighter than Jupiter, I think. Anywho, bright
Yeah,
planet.
I have to check.
Yeah, and as we move forward in time, I'm actually going to take us later in the evening.
But I'm going to close that window. That's driving me nuts.
Okay, go for it. As we go along, so there's three, it's the third, the fourth, and then the fifth. The magnitude's getting brighter. So I know it's getting technically a smaller number, but the smaller number, the negative 2.5, for example, as it gets smaller, it's actually getting brighter. So it's getting brighter as we go towards its closest approach date, which is the 6th. And then, oh, hey, technically the 7th, it's brighter. How is it getting brighter all the way to opposition? That's fair. Okay.
Oh, yeah, it could just be a sun angle and.
Yeah.
Yep.
So there you go. Nice and bright. Lots of time to see it. If you want to get a really good view without the atmosphere, definitely head out a little bit later into the evening because it will be higher in the sky. So this is around 11:45 on whatever it is, the 4th. And it's getting pretty high in the sky at that point. You can also, I mean, if you want to get really high in the sky, then you can go out at 2 a.m, but that's not me. I'm not that kind of astronomer. So you have lots of opportunity to see it. And the other nice thing is that since it's visible all the way from sunset to sunrise the next morning, you have a really long time to image it if you did want to image it. Alrighty, so there's Mars. Our next target on the planetary list is Venus. And unfortunately, you will have to get up early for this one. It's only visible in the morning. Oh, and I've already gone too far. It's the 1st today. So this is tomorrow morning that you're going to want to get up early or the next morning. So Friday morning or Saturday morning, depending on what your weekend looks like. You can technically see Venus all the time. Well, not all the time, for the next couple, about a month or so in the morning. But the reason I'm saying get up tomorrow or the next day is because it is conjuncting. It's getting really close to a star. And it's the star that's in Leo. And you can see, I'll bring up Leo. There's the lion.
Oh, Regulus, yeah.
Regulus, yeah, at the front of the lion. So you might be able to see the backwards question mark. It's probably easier to find with Venus close by. If you do get up, Leo is one of the constellations for Explore the Universe. So you can say you observed Leo. We talked about it early in the season, like early in July. So if you missed it then, you can go back and see it now. So on the 2nd in the morning, so that's tomorrow morning in like 12 hours, it's going to be super, super, super close to Regulus. So we're talking less than a degree, like just over half a degree. So it's definitely worth a view. Venus will be, it's not as big and bright as it could be because we're actually seeing quite a small portion of it. I'll zoom in.
Yeah, because Venus is between us and the sun. So like if it were perfectly between us, it would almost be like a new moon, right? So
yeah, so the Venus is a weird one in terms of observing. Like as the amount of Venus that is lit up gets smaller, it actually gets brighter because Venus is closer to us. And so because it's closer, while less of the surface is lit up, more area is lit up as it appears to us because it's closer.
Yeah.
But either way, still a great thing to see.
Constant trade-off, yeah.
Constant trade-off. The one thing about observing the planets I find is that if you stop paying attention for a couple of months, it's really hard to figure out where they've gone. If you're not like super tuned in. So I briefly, when I transitioned from working at the Ontario Science Centre and doing planetarium shows every day to working at RASC, where I did not do planetarium shows every day, I lost track and I had no idea where things were because I was learning about office stuff instead of space stuff. I already knew about the space stuff. So hopefully this program can help you keep track of that stuff for now. Venus, and you can watch this over a couple nights, it's actually getting closer to the sun. So as the sun's rising, it's staying in more or less the same spot. Kind of cool. And eventually it will be blocked out by the sun. So it'll move all the way into the sun's, there we go. We won't be able to see it. So that'll be about December. It'll be too hard to see.
Yeah. And if you wait till 2117, or
Oh,
there'll be another transit. I'll be 140
2117.
something. Yeah.
Yeah, it's real achievable.
Yeah.
So maybe by that point, the people who are being born now will live to be 100 years old, and they will be able to see that transit.
Yeah. That's when Venus goes in front of the sun. Happens about twice per century. And they're always close together.
I hate to tell you as well, but we missed it this year or in this century because that was back in what 2008 and
26 and 12, I think. I caught the 12 one.
Yeah. It's 2008 and 2012. Yeah.
Right.
So yeah, we missed them. That's okay.
You can watch Mercury go across the sun, I think.
Yeah, that happened in 2019.
That happened in 2019 on Remembrance Day, and then it'll happen again in, I think, 2032, I think, is the next one of those.
Okay, that's not far. On that note, though, let's talk about why we can't see Mercury, why I made that mistake. So earlier I had been, actually, I'm going to take us back to the morning. Earlier I had been talking about how, last session, about how now is the perfect time to see the zodiacal light. And that's because the ecliptic is like extremely vertical compared to the horizon. And I can show you that here. You can see in the morning that the ecliptic is nearly vertical. It's at this really steep angle. However, in the evening, as the sun makes its way across the sky, the ecliptic is really at this steep angle compared to the horizon. And the reason I'm mentioning this is because Mercury is at greatest elongation right now, which means it's as far away from the sun as it can get. So it's as high in the sky as we can see it on this particular spin around the sun. But that doesn't matter because it's still so low on the ecliptic, and the ecliptic is so close to the horizon that we won't be able to see it, which is a shame. So let me bring up Mercury. Nope. I do this several times when I'll type Mercury and then I have to get rid of all of the things that I brought up.
Yeah, it's like, because you got to click into the box before you start typing. Otherwise,
and it has a little flashing thing and it tricks you.
Yeah.
Anyway, back to Mercury. So here's Mercury. So dim you can't even see it. There it is. But it's way, way, way too close to the horizon right after sunset to see. So that was my mistake when we set this up. Even though it's quite far away from the sun, it is, let's see. Yeah, it's 25 degrees away, like a full hang loose gesture away. But it's just the ecliptic is too low to the horizon. So no Mercury this time around. If you do want to see Mercury, you're going to have to wait for another couple months when it comes to the other side of the sun and we can see it in the morning. Sorry, everybody. But for that reason, because we have certain targets that we need to see for Explore the Universe, you may not be able to catch enough of the planets in this period of time to acquire enough solar system objects. So the other alternative, and I recommend doing this with Mars, is plotting orbital motion. So how the planets move. This one I've never actually done myself, but I think it's a really cool, wow, nope. There we go.
So how much orbital motion do we need to plot to get to check?
I don't think I've actually asked. I would say go and observe at least twice, maybe 3 times, because then you get a better idea of the movement, but it doesn't have to be right one day after the other. You can wait a couple days in between, and I will show you with Mars this evening. So let's say you're going out to observe Mars, and now would be the time, right? So you can go out and take a look at it, and you've got, let's say, these 3 bright stars nearby. Maybe you want to add in some of these stars up here. And then the next day, you go out and you look at it again. And now it's moved to the west a little bit, figuring out cardinal directions. And so then you plot it again next to all these stars. And then you go out again the next day, and it's once again moved a little bit more. And now it's closer to the star. So that by drawing Mars compared to the background stars, you can figure out which way it's moving over time. And that it's moving at all.
I think it'd be neat to see, if you're plotting enough, it's going to do like that.
Yeah, it's going to do a big curvy swervy thing.
Because as Earth passes it, and from your location on Earth, it does a whoop. That's what astrologers are all about, that retrograde. But
yeah, that's what one day we'll do. We'll do an episode on what astrology means, not that what astrology is per se, but what do they mean when it's retrograde motion and all that sort of stuff. So I'm going to show orbits. No, that's not what I want. I wanted to trace. Maybe I can't do this on the fly. Do you know how to trace objects?
Not sure.
Nah, okay.
But going back to astrologers, a really fun thing to do if you've got stellarium is to go put their birthday in and go back to the exact date and time they were born and show them what constellation the sun is in, because that's technically supposed to be their sign. And I guarantee for about half the people it won't be the same one. So like I'm an Ophiuchus.
No, one of the new
according
ones.
to my astrology sign is Sagittarius, but like by the rule,
they're all messed up. We'll do a whole nother thing on the zodiacs.
It's a fun thing. If anyone wants to do that, you should do it and see what your actual sign is. It's kind of fun.
For sure.
Yeah.
Also, Alistair Ling has corrected me, and I appreciate how knowledgeable our members are. And Alistair also contributes to the Observer's Handbook. November 10th is the next time we'll be able to see Mercury. So you don't have to wait that long. So go to the other side, and that'll be in the morning. Show trails. Thank you to, I forgot to catch your name. I'll shout you out a few minutes later. So if we jump ahead a couple of months, I'm going to zoom out. You can see the movement of Mars over time. And it does, whoopsie, we'll zoom back a little bit. It does this like little funky wiggle as we pass it. And Chris Vaughan had a really good metaphor for this, where if you're passing a car on a highway and there's a mountain in the background and you're watching it, you approach, and the mountain is the background stars and Mars is the other car, and then we're Earth in our own vehicle. And we catch up to Mars, and compared to the background, it seems to drift backwards as we drive past it. And eventually when we're far enough ahead, they both move together. But for a brief period, Mars, the other car, is moving backwards compared to the mountain in the background. And that's what this little wiggle is. So yeah, Dave Chapman says if you want like gold star status, you can plot that wiggle. Up to you.
You get a special thing on your pin, like in Rotary, where you get the extra dot. You can have an extra dot.
Wiggle. Yeah. So that's it for our planetary stuff. So that was, to recap, that was Mars, Venus on tomorrow morning if you can, or the next morning if you want to, and then orbital motion. And now for our non-planet targets, and also Mercury was my bad. We can't see Mercury until November 10th. Now for our non-planetary targets, we have 3 this week. They're relatively simple, except for one of them is going to be a bit of a challenge. The first 2 are constellations, and we're getting into the autumn constellations because it's finally fall. So let's go back to not January. And we're in daytime. Perfect. There we go. All right, so here's our night sky tonight, and these will be visible for a while. I'm going to bring up the constellations so we can see everything up here in Orient. So as you know, we've got our summer triangle here, and it's a summer triangle because it's a triangle that we see in the summertime. Our next one is also creatively named the autumn square. Gee, I wonder why. It's a square we see in the autumn. Creative astronomers. So in this case, because it's the autumn and the sky moves generally, well, it appears to move for us east to west from day to day. As we move through the autumn constellations will be rising in the evening. That means they're going to be to the east of whatever's up there. And so if we're looking for the autumn square, we're going to be looking to the east. Can you see any squares standing out over here somewhere to the east?
I was looking for, I call it the Great Square in Pegasus. I think that's what you're talking about. I've never heard
it. You're right.
That's new to me.
You never heard the autumn square?
No.
Maybe it's just something we made up at the Science Center then.
I like it though. I like it.
It works.
It works, yeah.
Great Square. So yeah, John's right. It's Pegasus.
I find the autumn square though, like once you move out to binoculars and telescopes, a little anticlimactic because there's not necessarily any interesting deep sky objects in it. Whereas the summer triangle is just packed with fun stuff for everybody. Like astrophotographers love it for the veil and all sorts of stuff. Binoculars for the coat hanger and the double stars, and telescopes for the dumbbell and globular clusters. It's like got everything.
It's true. You're right. Yeah, it is pretty cool.
The square is notable that it's empty.
There's nothing to see.
There's nothing here. Fun. There are 2 globular clusters right to the west of it.
Okay.
Yeah,
Like out over here somewhere.
over there. Yeah, there's
Okay.
two.
See,
But
okay,
that's
so but as a storyteller, I like the Autumn Square because Pegasus has some cool stories around him. And in some cultures, it's not a horse, an upside down horse at that, which I find a bit silly. In, for example, in Ojibwe culture, it's a moose, which is, I don't know, I like it. It's got, and it's also, I mean, like the main thing for me is that it's signposts, right? Like it's how you find your way around the night sky. So it's an easy one to
yeah,
see.
totally.
So it is an upside down horse. I've heard people say it looks like SpongeBob. It looks like a creeper from Minecraft. I do mostly shows for kids. Can you tell? There's lots of different options. The kind of cool thing that one of the parts that I like about Pegasus is that he was a horse known for not losing a lot of battles.
Yep.
And so because he always won, he has a gold star at the tip of his nose. Aww.
So Dave, I think is it Algul, Dave? So Dave says trivia, which star in Pegasus isn't technically part of
Ooh.
Pegasus? Because that right to the left of it is actually that like arm is Andromeda constellation, right? So that oh no, it's not Algul.
It's Alpharaz,
right?
yeah.
Yeah.
So this one's a neat story because for a while, well, Pegasus was its whole self, and that was part of Pegasus. But Andromeda needed a head, and so they gave the star to Andromeda instead.
She was missing her head. Okay.
Her head. So those two are the two constellations for this week: Andromeda and Pegasus. So when you're looking for Pegasus, you should, even in Toronto, you should be able to see the 4 stars of the square. And you can, if you can't. I don't have a ton of tips because they're tricky to see, but when you know about the area in which to look, you can see them pretty clearly.
I usually use Cassiopeia and just point because you're used to using Cassiopeia, as part of the W as an arrow to find the Andromeda galaxy,
which we did last week.
Yeah. And so you've got this, you're already sort of oriented to those stars in Andromeda, and then so you can just scoot over to the big square if you don't see this big square right away.
Yeah, okay. So give that a shot. The other thing too is that we saw the Andromeda galaxy last week. That's right here. And it's named because it's in the Andromeda constellation. So while we use Cassiopeia to find it, it's Andromeda that we use, that it's inside of. And you can see how it's really close to the stars in the Andromeda constellation here.
Yep.
So once you found that square, I don't think I've ever consciously observed Andromeda. I've always pictured it as the back leg of the horse, sorry, and not its own constellation, which I should get that right. But yeah, those are the two. Just Pegasus and Andromeda are the two constellations for this week. Give them a shot.
Cool.
The next target is a hard one, and I have a bone to pick with the observing committee about this. I actually, so I don't know if you have kept up to the Google calendar that we had set up. If you haven't tried it, we're almost at the end of the program, so maybe it's not useful, but it had dates and reminders for everything that's happening in our program and when to go out and look at stuff. And I don't know if you looked carefully, but the description for this one was, okay, I haven't figured it out yet. I'll get back to you later. So I have since figured out how to find it, but it's tricky. This star that we are looking for is Delta Cepheus, I guess.
Yeah.
Delta Cephei. Anyway, it's the Delta star in the Cepheus constellation. I have a bone to pick with the observing committee because the Cepheus constellation is not in the Explore the Universe program. So if you find the Cepheus constellation, which is this weird house box looking thing, that doesn't count for the observing program. However, this is a double star, and I understand why they chose it. And it's because this double star is also a variable star. Variable stars are something that you can observe if you want to. They're not in this program. They change brightness over time regularly. So Betelgeuse is a variable star, and when it got all super dim and everyone was like, oh my God, it's going to explode, that was because it was in a dimming cycle of the variability of it. And the particularly cool thing about Cepheus, about this variable star, was that this kind of variable star can give us information about how far away it is. And those are called Cepheid variables. So this star that we are looking for is the Cepheid variable. It is the Cepheid
It's
variable
already in
after
the
which
name, yeah.
Cepheid variables were named.
So these are very important in astronomy history, and it's neat because this is what, if you know their periodicity, then you can figure out, their brightness, and if you know your brightness, you can figure out the distance. But it blew my mind that, so what Edwin Hubble did, because before they knew that there were other galaxies, they thought galaxies might be just nebula in our own galaxy, and that our galaxy was the only galaxy in the universe. But Hubble used, after they figured out what Cepheid variables were, he could then look at Cepheid variables in the Andromeda galaxy and determine how far away that galaxy was, and he proved that it was another galaxy. What blew my mind, I'm like, well, how can you isolate one star in another galaxy? Like, how, what? And plus he's using plates of glass with, photosensitive chemicals on them to like make these pictures, right? Mind blowing. And then so it was a while before I realized Cepheids are huge stars. They're huge. And that's like many, many times bigger than our sun. And that's what made them a little easier to identify in other galaxies, to let Hubble do what he was doing. So I don't know. That blew my mind.
Cool.
I thought
that is very cool. Yeah. I'm actually going to briefly pause the sharing in Stellarium before we even get to talking about how to find this particular star, just to show you. So John was talking about, so many things are popping up on my screen. John was talking about the slides that Edwin Hubble was using to find the Cepheid variable in the Andromeda galaxy. This is the slide. And it's,
I've never seen this. That's beautiful.
Oh, it's so cool. So the thing was, he was looking for novae, which are new stars, which you can see by the little n. And so he noted that he saw a nova here and a nova here, and then he noted this nova here, and then he scratched it out and wrote var, which means variable. And that was the variable that made us realize that we're not alone. Cool, huh?
That is cool.
It depends on your definition of cool. I think it's cool. So this is not that star. That star was in the Andromeda galaxy. This is just the type of star after which these stars were named. So to find this Delta Cephei, I think, we're going to once again use Cassiopeia, our guidepost to the universe, because it's easy to find. It'll help us find Cepheus, the constellation here. So all you have to do is look for this side, like the deeper side of the W, the last two stars, and that'll point upwards away from the Andromeda galaxy and everything towards this little square.
Yeah. And note that this is very far to the north. So this is the northern sky. So
yeah, you're right, it is.
Because I think of this as like the northern square. So I'm always looking for that box.
Okay, that's fair.
Yeah, so if you're using telescopes and stuff, there's lots of interesting open star clusters in this area. So it's a good constellation to know. And I find a lot of the open clusters in here look like the swimming alligators in there. And there's one I call like the water snake. There's lots of
it's all aquatic.
Aquatic animals is my theme for this part of the sky.
That's cute.
And so it's sort of like, this to me is the northern box, to go with the box.
Fair.
Yeah.
Fair. Oh, look at that shooting star. Not a real shooting star, to be clear. So yes, then the northern box, and it looks like that's something cool over there. Anywho, so once you find this little box, I haven't got a very good tip for finding this. I only know this is where it is because I've looked for it. So this star here is Delta Cephei. It is a pulsating variable star, so that was that Cepheid variable we were talking about, and it is also a double star. So I guess you're looking for the star that's closest to Pegasus here, but it doesn't form a triangle with anything. It's just kind of like this forms a little T.
I mean, I would just use the side that it's from Cassiopeia, that Cassiopeia almost points at that star.
Yeah, that's true. So the side that Cassiopeia is pointing at, and John, you're right. It nearly points at the star, but it's off a little ways.
And does it have the period? Oh yeah, the period's 5 days.
Oh, cool.
Yeah. So, and what does it say the change of brightness is? Something. Anyway, so like hypothetically.
Oh, it's 3.48 to 4.37. So still pretty bright.
Hypothetically, you could look at that, every few days or so and see if you could notice the brightness compared to that neighboring star in Cepheus, the constellation.
Yeah, you could. Yeah, you could check and see like these two, although that's also an eclipsing binary system. But it stays pretty
added
close.
complication.
Yes. So yeah, this is the field of view of binoculars. And so if you follow those two and continuing that straight line, first without binoculars to find this side of Cepheus, as you look at the corner of Cepheus, here the corner at the top of the side that Cassiopeia is pointing to, it'll be the bottom of the T shape.
And someone's asking if they can see the separation. 21 arc seconds is the separation. I would say, yeah, with telescope. I don't know
With
which
the telescope,
star.
yeah. This was suggested for this target. It was suggested to use tripod-mounted binoculars or a telescope. So you may not be able to separate it with basic binoculars. It's a trickier one, but its historical value, I understand why they included it, because the historical value is important.
Totally. I mean, Ceph variables are really cool. Like from a scientific standpoint, they're fascinating because the whole star is literally growing and shrinking by possibly tens of millions of miles.
That's
every
so cool.
5 days. Like if you were in that system and saw this, thing growing by millions of miles every 5 days, like you would see it in motion, right?
Yeah, for
it's
sure.
So stars are always, you've got this outward pressure of radiation from the fusion and this inward pull of gravity, and they're always fighting with each other. And in variable stars, like for a while the gravity's winning, and then for a while the radiation pressure is winning. So that's why you get this cool pulsing that goes on for millions of years.
Very, very cool. And at some point, at some point we're going to host a session, I hope, on ways that amateurs can contribute to astronomy. And so observing variable stars is one of those ways, and we'll get into more depth later, but basically what you can do is look for the change in brightness of a star compared to another star that doesn't vary. Unfortunately, this is like surrounded by exclusively variable stars. But then let's say, for example, Betelgeuse. A lot of people, when they were observing Betelgeuse, when it was getting really dim, they would compare it to stars in the Big Dipper's belt, or some such, and see if it's gotten brighter compared to those or dimmer compared to those.
Yeah, it's actually kind of cool. There's two ways they do it. One, photographically on a computer, so you can just literally take a picture, and then on one night, and then you select your star that's not changing, or a couple stars that don't change, and then your variable star, and you can record the brightness that way. And then there's another way where there's a device. I haven't used it, and you can sort of do it visually somehow.
Cool.
Without the computer side.
Yeah, the computer side is pretty tricky. If anyone's curious about that, we actually have, if you're really into astronomy, we have tutorials up online on how to measure exoplanet transits, which are very similar to variable stars in that the star changes brightness, and you have to measure how bright each of the pixels are that make up that star. It's the same method, except you're using data probably taken over a longer period of time.
That's about a 3 hour. So for me, when I did my exoplanet observations, it was 3 hours about.
Okay,
yeah.
And it depends. You can get anywhere really between like 1 hour and 5 hours, sort of.
Yeah. A lot of fun though.
Super fun, definitely worth it. We even have, actually, if anyone's curious, we just launched a grade 9 program about measuring exoplanet transits. And so we have data sets available for download where you can download them, and they're already calibrated and they're ready to be processed. You can go into AstroMSJ and look for that little dip. So that's on one of our websites. One of those things where I'm like, I can't believe people who are just like amateur astronomers would be interested in it, but I will find the link and I'll send it out just in case. That's it for all of our targets this week. John, did you have any like other extra stuff that you wanted to add? We still have 15 minutes. We haven't told any personal stories yet.
Oh gosh, so many. Can you hear me okay? I just got the you are slow symbol.
Yeah, no worries. I think I can hear you anyway.
Okay. Yeah, I don't know. So personal stories. I thought I lost these binoculars. These are my 7x10. So these are my favorite stargazing binoculars, and I thought I had lost them. And so I went to Canadian Tire today and I bought binoculars because I was making a binocular YouTube video today for my channel, Learn to Stargaze. You should follow me on YouTube, Learn to Stargaze.
Plug in John.
And so I've basically been trying to make one YouTube video per day and then releasing them every 3 days. So today I was making binoculars, but like an hour after I went and bought these, I found them. Now I have like the pile of binoculars back here.
Silly John, all your binoculars.
I also bought Since we last talked, I've only bought 3 telescopes.
Well, you're the reason
So,
I think the
but
entire country is
and so
cloudy.
because and Dave Chapman, I'm just gonna be like swimming.
Okay, now your internet connection.
I know it's totally my fault. Yeah.
Okay.
So a lot of people are buying this one, and I would say don't necessarily buy it unless you're willing to alter it. So this is the Celestron Travelscope 60. This style has become really popular on Amazon, mainly because of some fake reviews. But it's on a camera mount, and so there's a lot you have to do to change it to make it into a good astronomy telescope. So I was making a video for that. And then there's a telescope because the holidays are coming up, there's been a telescope that I've been recommending to people who want an entry-level budget telescope that doesn't suck. And so I ended up getting this at Costco. Anyway, so that's been my week.
That sounds like a good time. In the time so your internet has been coming in and out, I think, or mine has, but I think it's yours. But in the time that you've been telling us about all of your expenditures on telescopes, we've got a couple questions. So first of all, will you be able to view the double star that we were talking about with binoculars that are 7x50? Probably not. That might be a little bit too low magnification. So for this one, you would need a higher power magnification binocular sitting on a tripod or a telescope. And so if you can't see this one, there are others that you can find as well that we've listed. And we can also focus on some other ones maybe in the upcoming sessions as extra spares if you need extras. And from Janine, 2 questions. Image stabilized binoculars, thoughts? I think they're a really cool idea. I don't know if I'd have the money for them. And John, you're coming in and out a little bit. What's your opinion on image stabilized?
Yeah, so I think Canon, can you hear me?
Kind of.
Okay. There's a pair, so I've used them and they're awesome, but I'm not sure they're like $1,000 awesome.
Yeah.
So it depends, like if you really love stargazing with binoculars, like really love it, then for sure, go for it.
I mean, it's like having portable telescopes that work on both your eyes, which is really cool. So it's pretty neat. Yeah. It's just expensive. Yeah.
There is a pair. There is an entry level pair that Canon makes for. It used to be $500.
Oh, cool.
But most people get the one up from that. Mm-hmm. But it makes a huge difference. Like you're looking and stuff just stops. You hit a button and stuff stops bouncing.
Oh, so cool.
It's amazing.
Pretty cool. So that's like a cool techie thing to get. If you're into whoever you're buying them for, yourself or someone else, is into like cool techie stuff. Like I know my dad would love them because he's a cool techie guy. Another question from Janine. What's on our Christmas lists? John's already bought half of his apparently.
Yeah. So I'm going to test this telescope and do a review and see if it is the optimal telescope that can be gifted. Because a lot of people buy telescopes as gifts and they're not great. Like they'll buy this one. I'm hoping that this one checks all the boxes for a beginner telescope that's completely easy, the easiest thing in the world to use. Doesn't break the bank and is a lot of fun. Anyway.
Cool. That sounds good. Yeah. I honestly haven't thought past next week, so I cannot think of what's going on at Christmas time. I honestly, and this is going to sound cheesy, but you may see this in the next Sky News as well. I just really am looking forward to spending time hanging out with family and drinking hot chocolate and showing the people in my bubble the night sky. That's what I'm looking forward to for Christmas. Hopefully there will be some nice opportunities to do that and cuddle up around in the snow and stuff like that.
We're looking forward to a baby. So
what?
Yeah, I'm announcing it. I think some people already know.
What?
Dave, I think knows. Yeah,
oh my
Boxing
God.
Day, due date of Boxing Day. Yeah.
Congratulations to John. That's an exciting announcement.
So I'm preparing. By
You're buying baby-sized telescopes? Yeah. That's the perfect. Why would you need a crib when you could get telescopes?
Yeah. I know. Well, you could just hang them sort of under the tripod.
Yeah.
In a basket.
Get a jolly jumper and it's just like just hanging from the tripod. It's perfect. Wow. Okay, so that's very
Yeah.
exciting. I don't
And
know how we can top that.
I'm not going to tell you the name.
Is it
What will
astronomy-related?
top it is when you find out the name, which I will not tell until he's born. But
Okay.
everyone's gonna lose their mind.
We know it's a boy,
It's
though.
very space themed.
Oh, I can't wait. I'm excited. Very cool.
Oh my gosh. Yeah.
I don't
So
know how we can end. I don't know if there's anything else we can say.
I think
Yes,
we're good.
actually, next, please send your guesses for John's child's name to my email.
I will. Here's the thing. If anyone guesses it correctly and only give people one guess, I'll send them this telescope. They can have it. They might not want it, but if anyone guesses correct, I'll literally put that in the mail and they can have it.
Okay, but you have to guess. You have to guess first,
Well, you
and
you get one guess.
send entries. Actually, you know what? Send entries to your social media. There you go. Plug. You want to try that?
You get plug. Learn to stargaze anywhere. Twitter, Instagram, Facebook, YouTube. Yeah.
I'm gonna.
And yeah, one guess, and it's a very normal name. Like you'd hear it and you'd be like, oh, yeah.
Okay.
But it's
All right.
super.
So spontaneous contest, win a telescope and guess John's new child's name. Oh man. Okay. One last comment from Dave Chapman.
Hopefully we're not violating any like gam. Sorry, internet's slow.
That's okay.
On.
That's hilarious. So there's a quick comment from Dave Chapman, who apologized in advance for the fact that the Explore the Universe program is 18 years old. So some of these little things like why Cepheus isn't in there could be left over from the fact that it's 18 years old, and we don't feel that we can change it because then the people who got it 18 years ago would have gotten it under different circumstances to the people who get it after the changes. Since we have the time, and I know this is a denouement from your baby announcement, I apologize. There's a question from Lisa Ann Fanning, who says that they use a birding spotting scope. Is there a way to figure out the telescope equivalent? And I don't know if you mean like magnification or if you mean quality. If you have them, I don't have a good answer for that either. If you have the magnification of the spotting scope, which I assume would be the way that they would market it, would say like 10 times magnification or 15 times magnification. You could, is it me cutting out or is it John?
Yeah, I mean,
there we go.
You're pretty slow coming through on my end, but I can make it out. So what's the difference? I mean, scopes, for the most part, scopes are scopes. I mean, a lot of it just has to do with the mount. So telescope mounts can be tilted up usually a lot more comfortably. And they have like this, you'll have this diagonal on a birding scope and, you know, a 90-degree diagonal on a telescope. So birding, telescope. And
so
then,
yeah, it would be more
the mount that enables you to.
Yeah, it would be more about, it depends on what you're looking for. If you're looking for a match on the magnification, then you could do the calculations to figure out what the magnification of a telescope with certain eyepieces would be. And so if you wanted the exact same magnification at like a standard eyepiece of 25 millimeters or something like that, you could find a telescope with, if you wanted 20 or 60 times magnification, you could find a telescope with, oh no, math, the right focal length.
Yeah, so I would like this telescope. This is the Celestron 100 AZ. It's f6, like even this big one for astronomy, but that's wide enough. It would make an okay telescope for birding too. And someone suggested this is also an erecting eyepiece, so that flips the image so it's right side up. So you want that as well.
Right.
So you're not looking at upside down birds.
So this depends as well. Yeah, if you want a telescope to bird or if you want to use your spotting scope to observe space, it kind of depends on which way you're flipping it. So yes, if you want to use it for birding, then you have to get that 45-degree thing that John's been showing. Okie dokie. And the last question, which is one that I'm not sure I could answer. Can you detect Mars with a 15 by 15 lens? I'm not entirely sure what a 15 by 15 lens means. Like
so
15.
If you just talk about something that's small, or like, yeah, I mean, you could detect Mars in any, like,
yes,
you don't even need a telescope. You can just look, but it takes these high F ratio telescopes or a telescope with a lot of magnification, like Barlow's and, you know, low focal length eyepieces to resolve the disk. And a lot of the time it will just look like a bright star. And if you don't put the moon filter on, you might just see like the star shimmer coming off it, right?
Yeah.
Like
That's the loophole.
You need something to tone that down sometimes.
Yeah. The loophole is, first of all, definitely a filter helps. If you don't have, a tip, if you don't have a filter, wear sunglasses. They kind of work.
All right.
And then there's Lyra chiming in. And then the other thing too is that you can technically observe Mars just fine without a telescope at all. You can just look at it. It's, and everyone's, can I see X in this? Everyone's version of seeing, like, do you want to see the ice cap? Do you want to see the fact that it's a disk and not a point? Do you want to see just the light in general? Everyone's sort of what counts is a little bit different. So it's hard for us to judge, but you can try that website that John mentioned, the one that's the link was in the chat and is on YouTube. Go and put in your astronomy.tools and go and try it with your own optics. Okay. Well, I'd say you just muted yourself because you're a dog, I assume. I'd say we've covered a lot of stuff.
My dog's announcing the final goodbye.
That's it. The session's over. Thank you all for joining. Lyra has spoken. Thanks everyone for joining. Thank you so much for for all of your positive feedback and for your attention. And if you have any targets again that you want us to go over, please do let us know by email. Let me know by email. My email will be in the YouTube video description. It is jenna.hinds@rask.ca. And we will see you all in 2 weeks. Don't forget to come to our Mars events Tuesday next week and Tuesday the week after as well, which are independent of Explore the Universe. But John will be there on the Tuesday.
I'll be there with my new telescope.
With your new
the
telescope.
Big one, not one of these small ones.
All right, we'll see you next time, everybody, and have a wonderful
All right,
Tuesday.
Jenna.
Bye, John.
Yeah. Bye.
Take care. Bye, everybody.